Okay, this is issue number 37 where I try to hook up the GL calls to the main thread. This is picking up from issue number 36 where we were writing the shader stuff and we couldn't call the GL calls because it was on the wrong thread. So I'm just going to I want to continue working off of that particular issue where I left off on that issue because things were compiling. It's just we couldn't call the this particular call on the main thread. So what I'm going to do here is try to set the context off of the main thread, or off of the window thread, which is a little bit, I have some uncertainties there because of the begin and end paint calls, but essentially I want to move the GL clear and clear color, or clear color and clear over to being called out on the main, and then when it comes around to actually doing this paint call on the next iteration of the loop, it will just fall through to the begin and end paint and the swap buffers. So we'll see how that goes. So I'm going to take these two, I'm going to comment them out here. It's our cornflower blue color, and we're going to go to the main, drop them here as calls that we want to do. And so actually I'm going to take these and put them inside of the GL create shader that we had. So we're going to go over into the GLS non.js, and I'm going to say func clear screen, and we'll just make that a simple void cgl clear screen, and just direct function call straight into C. This isn't actually what we're going to keep around, but it gives me what I need to test here. So now we can just call gl.clearScreen and cut these two out, and I just want to do the clear screen check, as that is what is being removed from the window code here. And the next thing we want to do is we want to move the context to our Go thread over here after we've created the window. So let's look for where we bind the context. WGL make context current, HDC and rendering context. This rendering context, we create a context, WGL make current, that rendering context. Now, the cheesy way just to get this checked is to set up OpenGL context as being called after we create the window and before we go into the Windows loop. HWND. And we got this event shared memory that we're going to want to set down here. So it's good that that's separate. Do we even use this before this point? We use it to write the fatal here. So let's try this. We're going to say void create window. We grab these guys here, paste it there. This is the create window stuff. Put it out here, and we have this HWND. So we're going to return an HWND. So return null and return HWND there for create window. And then we're going to have create context, void window, create window context. And this is just going to be this code here. And we'll call this from Go directly. not in a go routine. And then window main is going to be the go routine. Instead of window title, we're going to pass in a HWND, HWND. And context error, rate fatal. So we need this in here. Okay. Cool. Excellent. Okay. So we're going to call create window. So let's go to 132 go. So we say HWND is equal to c.createWindow. Grab these guys, paste it in, and then we're going to create the context. I guess I can create the context as part of this. Just put it down here. So it creates the context also on that thread, and then here we can just say go window main, pass in the HWND, and off it goes on the separate thread. And that way the context is created here on this thread. Let's see if that crazy idea works. So here we need the ESM. That's right. So we're going to take this ESM pointer, put it in the main here, and then see what our next error is. Okay, there was no error, but I also don't see a window. So strange. I should probably check for that error as well. Check to see if we have a fatal here. If EVT shared mem is fatal, then or if it's not fatal, we're going to continue here to do the go. Otherwise, we're going to let it fall through to while it's not ready. So is that the only thing we write for ESM up here? ESM, create those two, and then shared memory. That's when we go into the set write state. Cool. So let's try and see if we get a fatal, if that's the problem. No, it is not. It just is existing. Okay. Okay, I suppose we can also set up this show window to happen up here. But I am setting this long pointer before show. I think it's fine. We have that null check in there. Let's see if that makes it any happier. So it's on this. It's showing on the same thread. That means that this event loop is going to run on a separate thread. Well, that made it happy to show, but the events aren't working because they're in fact on a separate thread. So we're going to see if we can be a little cheesy here and use the shared memory for doing the same availability setups. So the easiest way to do that is to create the shared memory, write that it's written, do the context as a separate function, but it will need the HWND. We can also see if we can, instead of doing that, we can also see if we can have it create the context separately. Let's just do void window create context, create GL context. Oh, I guess we already have that, but we'll just paste it here. as a separate call. We're not going to return HWND. We'll just take all this and put it back where it was. Right here. And then here's where we were creating a context. So I wonder if we can show the window, write that it's written, and then wait for the available, and we'll create the context in between there, between these two. Again, this is just a proof of concept here, so we don't need to make it too fancy or clear or anything like that. So let's make it so that we set the pointer, we say we're written, which means it's going to wait. In fact, we can do that. We can do that. Wonder if we can set this. Yeah, we can set it beforehand. Let's set the state to written, wait for availability, and then continue. So context should be created in Go here on Go main thread. And that's when we'll call this function from inside of window Go. Or not window Go, inside of Win32 Go here. So rather than saying HWD is create window, let's undo all this. Okay. We're going to say Go main window, wait till it is ready. When it is ready, we're going to do C create context. And we'll need the HWD outside of this event shared memory. We'll need to pull it out of it, which should just be a void. We're just going to treat it as a void pointer. So we can say unsafe pointer event shared memory as pointer. We'll create another function in here as data pointer, which is going to be from the start of the data. So as data pointer, and then we're going to wait again. Or we don't. Yeah, we need to wait again until it says that it's ready. So let's see the Win32. So it writes, waits for the context, shows the window, writes, and then continues on. Waits for the availability. We'll see if this crazy madness gives us what we want. So this create context now needs to take in the HWND here, and it'll need to take in the full event shared memory. So these two guys here. Okay, a little bit of madness, but I don't even know if this stuff is going to work, so there's no point in making it beautiful. And hopefully that will give us the context. So now I just need to write the HWND before we do written. We can say SM and well, we're going to mem copy this one because we're mem copying the pointer. So mem copy to ESM plus the start, which is going to be shared mem start. So writing to that destination the address of HWND, which should already be a pointer, and then size of an HWND pointer, ESM. So that should write the address of HWND into the data, which is then going to be looped back in. And we'll see what I did wrong and how it goes. Write fatal ESM. That's obviously because we didn't write. we don't have an ESM. We're going to paste it there like that. All right, what was the other errors? HWND redeclared. Oh, this needs to be the const char star title, window title. Window title incompatible. Oh, it's supposed to be a different type. It's supposed to be a wide char T. I'll just paste it in from Git. Okay, so now we're at the return null section. We don't need the null because this is a return. Declared here. Yes. Cannot use cgo 0 variable type unsafe pointer as HWD. So we're just going to change this to void pointer when HWND equals that. We'll just cast it out. I don't need to cast because it's a void pointer, but cool. Failed to find a suitable pixel format. And now we're into this guy. So the HWND is not happy with HWND. Oh, because it's a pointer probably. It's a pointer to a value. So this actually should be asterisk HWND. Got to dereference the pointer. Okay, something happened. I got a black screen. Let's make sure our clear screen is being called. Clear screen. TGL clear screen. So we have the clear color here and the clear. So I think that we are hitting the issue where likely paint is not being called every frame. And so swap buffers gets called initially, but never again after we start setting it. And we can get the HDC from the HWND. And maybe we should grab this handle actually out of shared memory and just make it a part of the window, just so I have access to it. Problem is the structure is elsewhere. So let's go to sharedmem.go, not sharedmem, window go. Here's our window, and we're going to have an unsafe pointer here. When handle unsafe pointer, and then we'll want to set this handle to the create window. So handle is equal to create window, which create window will return unsafe pointer. So this is a pointer to that pointer, so we want to turn the data into an unsafe pointer. Then we got to deal with the size of pointers. So the value at this address is the byte at this address is the window pointer. So we can technically read it. We're not dealing with 32 bits, and again, this is just a test, so we're going to deal with it as a 60 uint64 is going to be the pointer. So var hwnd uint64, and then we can do we do binary dot read, and is that the function I want? Might be bytes. Bytes dot new reader. Yep. And then we're going to read hwnd. Enough arguments. Oh, we're not going to read here. Reader. And then we can say binary read. That's the one I want. Return hwnd. This is not going to be a pointer, but we can cast it as an unsafe.pointer hwnd. And I would have to cast this to a uint ptr. A lot of steps there, but now we have the window handle here, so this should actually be w.handle. Okay, so now we have the window handle, so we have access to that outside of this, which means we can finally call swap buffers with the HDC. So we can get the HDC same way we got it here, and so let's go to window.go, and we'll just create a, actually we'll just create a very simple swap here. Func swap what do we call it there? Swap buffers. Call it, yeah, swap buffers. Buffers. Handle unsafe pointer. And we're going to call C Windows swap buffers, which we can just do here. Void window swap buffers, void pointer handle, get the HDC, swap buffers, HDC, and this HWND is going to be the handle that we pass in. So copy this. Okay. Swap buffers. So instead of window go, we can say swap buffers. We don't need to call that. We can just call swap buffers and then pass in the handle pointer. So now instead of the main, rather than calling clear screen, which will do GL clear screen, well, actually, we can say clear screen, and then we can say host.window.swap buffers and see what happens with that. Okay, cool. It's cornflower blue. So if I create the, let's try to call this and see if it errors out. It's going to call it a bunch of times, so not a good idea to do it like this. Cool, yeah. So the moral of the story here is that I need to create the context instead of go, and then I need to be able to call swap buffers outside. I can get rid of that here. So we're just doing, I don't even need to get the HWD or the HDC there. So this WM paint, we don't need to do anything instead of the WM paint, probably. Let's just try without doing anything in there. See what it looks like. course, Linux is another story, or X11 is another story. Cool, so that's working. Let's try to change the color slightly just to make sure that things are actually running. So clear screens, and we're going to take in, we're just going to do a static float r is equal to 0.0f, and we'll just do r, and then do r plus equals some small number, maybe smaller than that, and see if our colors are changing over time. Might not be a small enough number. Okay, let's try 0.0 and 0.0 on both of those. Yeah, there it goes. It's changing over time. So cool. I would say that that seems to be working the way that I want at the moment. So that leaves us with cleaning up the madness, making it a little more readable, I think. We'll keep the as data pointer. That one's nice. It's useful. But this is a little awkward here. So rather than is ready, let's see, what else can we do? We have these guys. So we have available, writing, written, fatal, quit. We can have one for shared mem, waiting, context. We'll just add that to the end. Awaiting context. So now we can go over to our main window, and we can add in a define shared mem awaiting context and 0xfd. Cool. Awaiting context. So what we're going to do is we're going to write awaiting context, wait for its availability, show the window, say that we've written. We've got a lot of ints here that we can work with, so we can just add another one. So we'll have awaiting context is FC actually, and then shared mem awaiting start. Oops. So here, instead of written, we'll say awaiting start. Now let's go to shared memory go. We'll add C awaiting start. And is ready is anything above mem written. So those both would be picked up by is ready. So we can go back to Win32 Go. Here we're writing. If it's not ready, we're waiting. We want to check any fatals here. So create window should return, or actually no, we can say if evt shared mem so is ready is start is equal to shared mem waiting start is context shared mem waiting context. So we expect this to be context. So if it's not evt shared mem dot awaiting context, then we're going to say that we have a fatal on our hands. So evt shared mem dot we'll have set fatal func evt mem set fatal, and we'll want to put a string in that memory at the end. So essentially this guy here is what we'll want to do. So let's see what the AI thinks, so I don't have to look up online. Put a string at with the fatal error. Message string message. You have any idea there, buddy? No? Well, I can turn it into... No, that's not what I was going to do. I can turn the message into a byte array. Message. And then we can copy it in. Of course, it needs to be for length message. I is less than length message, and I is also less than length E minus the start. I'll write the message. Cool. Good enough for government work. A lot of memory hacking going on here. Set fatal. Context. Create expected but wasn't requested. Okay. So then here we're saying we're waiting till it's ready, and then we're going to say if evt shared memory dot is start. So if it's not a start, then we also have a problem. Expected start expected but wasn't requested. So let's see how this reads. Call the main, wait for it to be ready. I guess I can just make a helper function for that. Func evt mem await ready for not ready. Do that. That's going to put it on a new line. Okay, I'll just put it down here. So now we can say evt shared mem await ready. evt shared mem await ready. Okay. So we await the ready. If it's not requesting a context, we set the fatal and return nil. Set the fatal here, return nil. Otherwise, we return that. HWD, yeah, it could be null, but that's fine. Okay, so now we've got it set up so that it creates the context and gets all of that set up and ready to go. Phew, that's that was some nonsense. HWD. I'm going to change this to HWD adder. Take this and do HWD is equal to that. And then we can just pass this, instead of doing all that stuff. Also, I can take this data pointer here. No, I can't. It doesn't like it. That's fine. HWND. And that means that over in C land, we can clean this up to just be that guy. I'm going to run this, make sure I didn't break anything so far. I broke something. Okay. Let's see if it was this part. No. Let's make sure we don't hit any of these fatals. Step over. We're good there. Wait ready. And it's not to start. Let's pass in HWND here. That would have panicked, I guess. Set fatal. Set fatal is not working as expected. So actually, before I fix that, I'll figure out what's wrong with this set fatal function. Oh. Of course, now we're getting a different error. Okay, let's try this again. Set fatal. Set E0 to fatal. Goes to the message. Appends it. Okay. Event shared memory is fatal. It's not. Event shared memory is set fatal. Oh, this needs to be a pointer. There we go. Now that should fatal out. While it goes to fatal out, I'm going to go over here, awaiting start. Yep, okay, cool. Awaiting start is D, context is C. So context did happen. We waited for available. Oh, okay. Let's go back here to when 32 go. If we're going to wait for available, we got to set it available. So after we create the context, we then want to say vt shared mem dot dot make available. And that actually wants to go into, let's see, we get the context request, we create the context, we say it's available, we wait for ready, and then we'll carry on. Start expected. Make available. Context is created. It waits for available. We make it available. Comes through. Call start. Wait ready. It's a pointer. If it's not ready, it does the for loop. And we make it available there. Okay. So event shared memory. Oh, create context. So we're going to have a we're going to create the context, make it available, and ready. Let's see if we have a race here. So we say context, and then it freezes and waits for available, which comes in here to write the context. Let's make sure that when we write context, we do write fatal. So it could be a fatal that's coming in. So if it is not start and not fatal, then we're going to write a fatal. So if it is not this and not fatal, we can have a if shared mem is fatal, return nil, else if it's not context. So we can do the same kind of thing here, else. So I'm assuming we're hitting another fatal. Start was expected but wasn't. Okay, so we aren't hitting another fatal. So what we are hitting is a write. So here we're going to the start, and what's happening is we're getting down into this section down here, and we're going straight off into that. So we can wait for available outside, I think. We're going to wait for the available outside of the loop because there are no events and it's just following through and writing written down there. You know, was the theory. Let's put this up here and see what happens. It's the same thing, so okay. So we're definitely writing that it's written. The question is, from where? Because we are seeing this context, and that's when we are continuing on down the code over here. Okay, I'm pretty sure we're hitting this window proc, and we're going through and doing some of the events in the window proc, and we haven't finished setting up stuff here, so I think we'll drop another just for posterity, waiting for availability. Hold on, let's see if it's, yeah, okay. Oops. I'm gonna wait for availability up here. As we're getting all these things set up, and that's an ugly thing to have an if statement essentially at the beginning of something just to clean things up. Okay, it keeps saying that it's set to written, and there's only 2 places it's set to written. I'm gonna get rid of those 2 places because this is madness. Oh, I know, that's fine. So it's set to written there. It's set to written there. You are never written, therefore you can never be written. Nice. Okay, I just moved the assignment of the user data down below the show window and added an additional fatal check after we create the context. So here we start the window, wait for the context request, get the HWD out of that because it was written to us as part of the context stuff. Create the context. If it's fatal, we need to exit. Otherwise, we're going to say that it's available, wait for it to be ready. If it's fatal, exit. Otherwise, if it's not start, we're going to throw a fatal. Otherwise, we're good to go. So this is the sequence of steps needed to make that happy. Now over here, we can just go in, we're creating it. Here we say we're going to write the state, awaiting context, wait for the context. Here, show the window, set the pointer, say that we're ready to start. Wait for us to get the available go ahead. Once we get that, we continue on. And that's going to get us to the point where we're back on track with our window with our cornflower blue. Now, of course, this unfortunately means we've got to deal with the OpenGL context in Linux as well for X or X11. Which context, create context. So that create context is happening. All this stuff here, glx make current. So this would be its equivalent of that context. So this is where we would write out the to the event shared memory. Write fatal, write fatal. SM, here's that SM I was looking for. So we can take this SM, put it up here. I mean, technically we can put it all the way up here just because it's going to exist the whole time. And here's where it's going to have the right, I just copy it down here, I guess. We're going to write the state for awaiting context. Win32. It's going to sit there, wait for the availability. This stuff is, wait a second, DW. Okay, actually we have this whole section all the way up to viz adders. The other thing is we have this S, which is used here, and again way down here. So we'll just take this default screen D, place it here, and then we'll move this down here. That's because this whole section, oh, we're also using it there, so I guess I'll just take it and put it in there too. This whole section from here all the way down to here is going to be the context code. So let's cut all of that and void window create GL context. Put it all in here. And of course, we're going to need the display, and that's the pointer that we're going to pass back like the HW and D. So I'll say void pointer display, D is equal to display. We'll create that GL context. Let's see what we do next. So we wait for that. Here we show the window, and then we go to the start, which we have here. So we'll write start. this is where our context weight goes to. So now we need to pass back the display, similarly to how we take the HWD here. We do a mem copy just before we set the context. We go here just before we set the context, and we want to pass in the address of D, which is going to be a display pointer. Display pointer technically. That means all of this stuff. It's going to be the same, unfortunately. Let's see. Yeah, basically all this stuff is going to be the same. So we'll probably wrap this C create context window into func create window context. This will be the handle unsafe pointer. Basically this goes here. And pass the handle in here. That means I'm going to have to change the pointer in Windows here to just be this. The event shared memory needs to come in as well. So I'm going to be passed. And that means this part of the code, let's go to where we call create window. Create window, and then we'll have create window context handle. And before we create the window context, we will grab this, which means create window no longer needs to return an unsafe pointer. We are just going to get it from shared memory here. W handle equals that. We don't need to return nil. So if not this and not context, do that. And not this and not that. Okay. So there we go. So create window is going to go create the window, make sure that we're awaiting context. In fact, we could even grab this whole section here, make this unique code even less. So create window, we're going to await ready. Make sure that we're awaiting context. And this is where we have an error, so we can just straight return that. Return errors dot new. So return nil and errors new. If we're not in the context, then this is where we grab this stuff and create the window context. If we are fatal, then return nil and the fatal message. Otherwise, we say we're available, await for ready to happen. If if we are fatal, then we're going to return the fatal message. Else, if we are not in the start, we're going to return nil and errors.new. Start requested. And that should make things pretty good. So now we've pulled all of that out. So we need the create context window inside of the x11.go. So x11.go, not this one, inside of windowing. We have the create window. We don't need to do this now. Func create window context handle unsafe pointer shared memory, and then we're going to call that function we made here. Window create GL context. Pass in the handle. Yep, and then we need to pass in the shared memory and size. And then, of course, we have to do the ESM. And I don't think we use SM anywhere outside of that. Cool. Context, build a context, wait for it. Do all this setup stuff, start. And then we can go into our loop. So let's at least make sure that we can build it on Linux here. Let's find the export. No, EXP. Oh my gosh. Let's just copy it. Build, export, run this build. See what errors we get. Window title in X store name. So storing the name icon. So this is just, this creates the window. Bconfig screen. So essentially we get all the way down here to creating the window. I guess the only part that is creating the context is here, but it's got a lot of concepts. Let's see. Leading up to it, what is W? Like W is the window itself. So we passed the display, which we're getting in open display. So we have display and we have window as two competing factors, and of course we can malloc up some memory that we can free to combine these two as a structure, and then move this top portion up to this section outside of the context. Play best FP config. This is set before we even create the window. These are quite tangled. I may need to do a separate pass on X11 just to untangle them on Linux. Okay, well, gotta do it. So let's do type def struct This will be X11 state, I guess we'll call it, and we'll have the display in here. I'll just keep the same naming, just to keep it simple. This window is a struct. What is window? I don't know what window is. Should be fine to copy it though. So that'll be our X11 state, and we will pass in state here, and we will say X11 state is equal to state, and then display D is equal to X11 state.D. And then take all of this up to where we are setting up the context down here, out of the picture, and put it right here. And now we're going to create our state. So X11 state is DW, and then this will be size of X11 state pointer. Actually, this will be size of X11 state pointer. The address of this will be written in. Actually, it have to be like an address of an address. X11 state pointer CPY state equal to the address of X11 state. Do some goofy stuff in here. So we make this the size of X11 state pointer because we're dealing with the pointers. Cool. And we just wait for the context here and then continue on with our business. So we need the D for, we also need the best config thing here because we're using that as well. So state dot best config dot best config, and then the window is being used right here, dot window. Heck, I'll just put it like this. We don't need to separate them out. See if that builds. First of all, clear. See if that builds. Oh, it's a pointer. Okay. Go build that. So now we are dealing with line 48 there. And we're dealing with, let's see, CTX is the context that we get out of here. So we can just, where does context get set? Okay. We can just, since we have the state, we can just set it. So CTX context, and we'll come down here to where we're using it somewhere. Destroy context. X11 state, this is going to be a dot now. Okay. A little hacky, but cleanup can be done in a cleanup pass. So now we need swap buffers. So 132.go, we have this swap buffers function for testing stuff. So we're going to create a similar swap buffers inside of X11 Go, but instead of swap buffers, we're going to use this GLX swap buffers. And the handle gives us that structure that we created. Where's our structure? Here it is. Let me just put this at the top. X11 state. Paste that there, and we can do D and W there. State. Oh, handle. Okay, undefined swap buffers. Of course, I gotta call it. So let's just copy this. It should be the same. Swap buffers. CGL create shader. This is using GLAD create shader. So we're gonna have to, I think, set up GLAD for X11, or do we? No, we have access to these functions. We have access to functions like GL clear, GL color, clear color, and clear. So we should have access to the other functions, I believe. So we can come over here and probably block this out. So if not defined, I think we set it to Win32 and not defined Win64. See if it knows what GeoCreate shader is. Oh, if it's this or this, we're going to include GLAD. Okay, so now it's, we're going to need to include similarly these two guys, likely, else. Let's try this. GL create shader, implicit declaration of GL create shader. So we don't have access to those guys. Okay, so instead of GLAD C, I added a define only for Windows because I wasn't using it at the time. So let's add that back in and deal with the consequences. glib, unreferenced, DL closed glib. This might actually just be a Windows subsystem error, which I can come back to. But also what this means is if I'm using GLAD, I'm going to need to also initialize it, I'm pretty sure. So Win32 init GLAD. Oh, this is the wrong file. Init GLAD load. Okay, so we're going to do this load. Here we're doing it after we set up the context. So I go x11.h, create context, and we can do the GL load. Okay. And we'll leave this for Linux to work out, but first let me make sure I include glad wgl as a header here. Am I doing printf? No, okay. I don't need that stdio. Windows.h. Windowing. Oh, it's coming from GladWL. That's weird. Oh, if not defined, when API. I think I can just include glad.h here. gl/glad.h. And get rid of that. Move this one down maybe. Okay. Failed to load OpenGL. That's because we did this here, so we can just write fatal out here. We don't exactly have to return, but you never know. Gonna add some more stuff later probably. Okay, and then I'll check this out on Linux, and we'll see how it goes. But let's make sure that, let's make sure Windows is still doing its thing with the clear screen, swap buffers, nice, still doing its thing. I'm actually going to delete this guy when actually I'm not even going to commit this main. Cool, I think that'll at least get us to the point where we can call GL functions on our main thread in Go. We just have to set up the context here on the main thread, and we're gonna make that setup context probably a little better in the future. But for now, it is what it is, and I want to focus on getting more of the systems up and running. Cool. So that's it for this. Okay, on Linux I had a couple of compile issues. First of all, I got rid of these clears because I'm doing those elsewhere. I just need to swap the frame buffers here. I also had to wait for ready here because this defer free is going to happen before the window is constructed, and it's going to use a null bad string. And then over here I had to set the best FB config, had to assign that in there. Lastly, or almost lastly, I noticed that this event wasn't being set, so I set the event. And then I noticed that I can't draw to OpenGL, I can't do any of the OpenGL commands after expose happens. So essentially what I had to do was set the event type to 0 here, which will tell Go to continue processing because it'll say, hey, there's no more events, go and do your thing. So we process the events at the top, we hit the expose, we do all of the Go code for moving things, rendering, doing all that stuff, and then we come back to the top of the event, at the top of the loop for Go, hit the event read, and we'll continue on from here. So we've written the state, we're waiting for the availability. When we get all the way around that loop and come back in here, we're going to say, okay, we're going to start writing, we're going to set the event type, and we're going to continue as if nothing ever happened. And this is just going to process all the rest of the events that have come in since then. So that's essentially what we had to do to get Linux working. Now I may have to do something similar to this on Windows on the WM Paint event. I'm not 100% sure on that yet. I don't think I need to because that Paint event doesn't need to be called all the time. Sometimes it's not even called. So I may just be able to leave it the way it is and just render whenever I want. So we'll see about that. That's just one note on that. And that's it for this.